Hello, I think this is on now. At some point soon, I know I'll have some viewers right now. We are just going live. And this is a pre-calculus study session for the pre-calc final. I am going to check to make sure that for some reason it's going a little slow. Hopefully it's coming in okay on your end. Because it looks like it's kind of choppy on my end, but hopefully it's working. I'm going to check in the live control room to see if I have any questions. The purpose of this, and sorry I started a little late. I was originally scheduled at 7 o'clock, but to be honest, I got a really bad headache coming home, and I went and take a nap, and I just kind of missed it. So I rescheduled to 8 o'clock. Hopefully I can still get enough people that it will, it'll help some of you out. So what I thought I'd do for this one is go over, answer some questions, and then also go over some problems that are going to be on the test. So what I'll do is basically I have the final right here in front of me. So I'll take a look at those, see if I can come up with some problems that are similar to the ones on the test, and then that might be able to help you. Again, if the connection is kind of slow and the voice is not, my voice is not coming in at the same time, because it's what it looks like to me as I'm talking to this. Hopefully it's not that way on your end. Okay, so what I'll do right now is first I'll go to the control room, and if you're on this, you can go on the chat. Let me know if it's working. For those of you that are my students, let me know if it's working on Google, on your Chromebooks. If it's not, I'll have to go in and change the settings, see if I can change that real quick. So we're going to pause for a second while I look to see what's going on. And you could probably hear my my daughter crying in the background. Something happened, so I don't know. She's crying of something. I think it's close to bedtime, so she's real screaming here. All right, so I turned off the microphone just for a second while my daughter was crying, but it looks like everything's working all right. The chat on, well, Google Classroom is working. If you have me on Remind, that seems to be working a little. That's going to be a little bit easier for me to check a Remind message as they come in my phone, rather than, or the chat on YouTube, rather than Google Classroom. But if you do it on Google Classroom, that'll work too. I'm just kind of looking at if you see me looking over here, I'm looking at my phone. Looking over here, that's my iPad, which I'll show you in just a second. So the first thing I'll do is I'll go ahead and take questions, and then I'll go through some examples here. So I know some of you had some things you wanted to talk about or some questions that you wanted to review. If you ask me a question about something and it's not really on the test, I'll just go and let you know it's not on the test, so that way you don't have to kind of worry about it. All right. Got kind of a lot of papers here. All right, let's see what we got here. Any questions so far? Can we see the final since it's in front of you? There it is. Ah, it's perfect. It's pink, right? You can't see anything. An A. Here, I'll open it up like it's a present, so you can see that part. It's blue. No problems on the back. Lots of multiple choice. Anyway, there's two different colors, I can tell you that much. Green and blue, but that's because there's two different tests. So will there be a, so Cameron asked if there's going to be a curve, and the answer to that is most likely. There was a curve last year, and there will be likely a curve this year. It really depends on how students do. So you know, the curve is not based on the highest, like some, you know, some tests are. The curve is really based on you know, a curve. So it's there to help the students that, you know, are in the middle and the bottom, and, you know, it's really not going to help those that really are on the top. So there will be a curve, but I'm not quite sure what it's going to be until after I grade it. I can't tell you this, though. This is something that's different, and I didn't talk about this in class, is that I will have you take the free response part section first, and then when you turn that in, I'm going to grade it as fast as I can, and then while you're taking the multiple choice part, I can grade the free response sections to see kind of how you did and get that done pretty quickly. Asia asked, do we get to use a flashcard? The answer to that is no, there's no flashcard. What you do get to use is a formula sheet that I will give you. So sorry about that, no flashcard for this pre-calc test. Can you do 3A and B on the free response part 1? I can. I got to look it up real quick because last page number 3 in the study guide. Okay, I'll do that. Let me get that real quick. That would be in my Dropbox. Ugh, it's tough to get rid of a headache. All right, let me get this up here. Okay. Number 3, are we talking about the verify problem? Is that the correct one? Or is it the piecewise function? I'm guessing it's the piecewise function. I wish you could nod and tell me yes, that's the one. He says, can you do 3A and B on the free response part 1? So that is. So I'm going to give you guys a gift. And that gift is that I am not going to actually have you graph a piecewise function like that on the test. So If you are taking the stat one, you do no longer have to worry about the piecewise function. It's not even in your test. If you are taking the calculus one, then I will actually give you the graph already, and then all you have to do is do the limits. So you don't actually have to do the piecewise function picture. All you got to do is the limits part. So if you'd like, I can go over the limit part with you and just kind of give you an idea of what I'm looking for in the limits and give you an example of that. So I'll go and do that since Christian asked for 3A and B. I'll go and give you that. And then Tyler asked for the verify. So I guess I'll do both of them for you, okay? So let me get my screen share here. All right, you should all be able to see my iPad. And so first I'll show you one where I am looking at a piecewise function and I'm doing limits. Okay, so this is for anybody that is taking the calculus one. So let's suppose I have a graph that looks something like this. Let's say I have a asymptote here. And something like this. And something like this. Okay, so this is just a picture I'm making up here. So let's say what I'm probably going to ask you to do is take a look at limits that are right at these like breakaway points, which would be like 2 here, 0 here. These are x values and -2 here. So look at something like find the limit as x. Oh, and I'd probably ask you as it approaches -infinity and as it approaches positive infinity, because that's end behavior. So let's say the limit as x approaches -infinity. So what's the y value doing as x approaches -infinity? What is the y value doing? That's approaching 0, because that's a horizontal asymptote. What about the limit as x approaches -2 from the left? Well, from the left means that I'm coming from this side of -2. -2, I'm talking about the x value. So I'm coming this way. So that's on this graph right here. What is this graph doing? What is the y value doing as I get closer to -2? The y value is increasing without bound, so that's going to positive infinity, or you can write does not exist. Either one works in this case. So what is the limit? The limit as x approaches -2 from the right. Well, as I approach from the right, I'm coming this way. So what's the y value approaching as I come this way to -2? And that's going to be 0. So the answer to this one is 0. Since this one and this one are not the same number, I would say that the full limit, the limit as x approaches -2, without a left or the right, does not exist. These guys have to be equal to each other for it to exist. Okay, so what if I change this? Okay, change this thing here. To 0 from the left and 0 from the right. So 0 from the left comes this way as I'm approaching 0 in the x. Now, even though f of 0, oops, sorry about that, guys. Done. Oops. Come on. Even though f of 0 is equal to, let's say 1, 2, 3, okay, that's the point right there. That's not what the limit is. The limit is as it approaches, as x approaches 0. So that's going to give me +2. So from the right, I'm doing the same thing. From the right, I'm approaching this way also. And I'm getting to the same number there too, same y value as 2. Since this and this are equal from the left and the right, then the limit as x approaches 0 is going to be 2. All right. So I'm going to ask you each of these little separate things. I'm going to give you the graph though, and I'm going to actually give you the function as well, but you really only need the graph. Okay, so that's what you're going to get on that. And then again, if you're taking the stat version, you're not even going to have this problem. So, you know, good for you. All right. Okay, let's look at the next problem, which was, I believe it was 3 on the other part, which was the verify, cosine x, cotangent x over 1 minus sine x is equal to, oops, to minus 1 there. Minus 1 equals cosecant. All right, so the rule of thumb for these is, well, it's not really a rule of thumb, but it's a rule that you want to try. You know, we want to go from the side that is most complicated to the side that's least complicated, and we want to make sure that we are, you know, using some techniques that I went over in class. So the first technique that I went over in class is changing things to sines and cosines. So if you see something that's pretty complicated with cosines and sines and then has something else in there, you want to change it to sines and cosines. This minus 1 is a little tricky there. I'm thinking that this minus 1, we're going to need a common denominator. So let's go ahead and do both of those at the same time. So I'm going to take cosine x, and I'm going to change cotangent x to cosine over sine. And I'm going to change 1 to 1 minus sine over 1 minus sine. So that way I have a common denominator, okay? So you've got common denominator here, and these are both exactly the same, which gives me a 1. Okay, so then I'm going to end up with cosine squared x over sine x minus 1 plus sine x all over 1 minus sine x. Now, if you're asking where did I get the plus, it's because I had to distribute the negative there. Okay. I got a little problem here with this little denominator here with this sign. So I'm going to want to do something with that. And the easiest thing to do, if I have one fraction in a big thing that's a big fraction, the easiest thing to do is to multiply everything, the top and the bottom, by whatever that denominator is in that little fraction. So I'm going to multiply everything by sine x. I'm going to leave the bottom the way it is. So I'm going to distribute this guy in here. Okay, this is going to cancel with that one when I multiply it here. So I'm going to have cosine squared x minus sine x plus sine squared x over, I'm going to leave this like this because usually what happens when I have something like this is one of these guys is going to cancel out. So notice you have cosine squared plus sine squared. Well, that's lovely because cosine squared plus sine squared is just 1. So I'm going to end up with 1 minus sine x over 1 minus sine x times sine x. These are going to cancel out, and I'm going to have 1 over sine x, which is cosecant. So there we go. All right. Oops. Messed up my thing here. Why did you multiply sine x again? I multiplied sine x because I have this in the denominator here, and I want to clear that denominator out. So the only way to clear this denominator out is to multiply the whole thing by sine x, so that when I multiply sine x times this entire fraction here, they cancel each other out. It's really blurry. I'm sorry, I can't help the blurriness. It's usually the if you hear my son in the background, it's because he's getting disciplined right now. He's not being a very good kid right now, right at bedtime. Okay. All right, so that's that one. Let's look at 3b. cosine to the fourth x minus sine to the fourth x equals cosine 2x. This is kind of a little tricky one. Notice here it's cosine of the fourth, sine of the fourth. We can actually do a difference of two squares. So we're factoring it. And then cosine squared minus sine squared is actually cosine 2x. And cosine squared times sine squared is actually 1, which just leaves me with cosine 2x. And I'm done, QED. So that one's kind of a quick, funky one there. Okay, getting a lot of messages here. What's the answer? It's blurry. I can't help the blurriness, guys. It's okay, I just changed the resolution. Yeah, you gotta, if it's blurry on your end, it's probably blurry because it's, you know, the resolution needs to change on your end. So okay. All right, so those were a couple of the examples for you. I'm going to answer some questions now that a few are asking here. One question was, are you going to be given a sheet of identities? On the sheet that has all of the formulas, it'll have all the formulas, all the identities in a table like you had before, all the ones that you'll need to use anyway. So I'll try to keep out anything on the formula sheet that you won't use. So everything on there you should need to use at some point. Excuse me. However, I am going to tell you this, that there's not a separate sheet for the separate formula sheet for stats group and calc group. You all get the same sheet. So there might be a few formulas on there that you know, the calc group will use and the stat group won't, and vice versa. You know, for example, I might put the formula for the IQR, the fences or something on there, and that's strictly the stats group and not the calc group. Okay, hold on a second. Can we go over finding polar points of the same value and position? Yes. See what the easiest way to do this is. All right. Okay, so there's a question here about taking a polar coordinate like -4, oops, and oh, man, I can't write today, pi over 3, and looking at where another point of that would be. Okay, the idea here is that, oh my goodness, always draw the circles first and then draw the line in between. Okay, so we're looking at pi over 3, which is right here. 1, 2, 3, 4. Goes down this way, and we got to go negative, so we got to go backwards. 1, 2, 3, 4. Here's my point, -4 comma pi over 3. Now there are other ways to get to that point. I don't have to get at it this way. I could start here and go all the way around to get to here, and then go out +4. So another way of writing that is +4, and then all the way. What's that angle that goes all the way over there? If you have a unit circle in front of you, you can take a look at that. I believe that is 2, 3, 4 pi over 3. So this is another way of writing the one that I gave you. Okay, we could have also went backwards, okay, and done a negative angle and still went out positive 4. So another way to write positive 4, negative 2 pi over 3. That's how we get here. So this is another way of writing this same point that I got when I first gave it to you. Finally, I could have gone all the way negative around here. Let me put this in red. All the way here, and then go back 4 units. Negative 4, and go all the way around here, which I believe is negative 5 pi over 3. So these are 3 ways of writing the same point that lands right there. I would encourage you, if you were doing this type of problem, which is definitely on the test, it's one of the multiple choice problems, that you draw your little picture out here so you know exactly where we're going. You'll get a blank unit circle on the test. I'm not going to give you a full out unit circle, but you'll get a blank one. I originally was going to post the answers for the study guide on Classroom, and I didn't get a chance to finish the study guide answers. So let me go check real quick on see if I put it in my backpack. If I didn't put it in my backpack, that means I left it at work, and if I left it at work, there's no way I'm getting it on Classroom tonight. Yeah, sorry guys, I did not. I left it in my classroom, and I apologize for that. I'll be in the morning. I really don't know what time I'll be in the morning, but you can come take a look at them and ask me questions. I'll try to be there. I'll try to be there by 7:15. Can you please explain 16 on part 1 of the multiple choice? Sure. Okay, so this is 16 here. We've got 3 vectors. Vector A is 15i plus 12j. Vector B is negative 4i plus 5j. Give me 1 second. I'm just going to check to see if I even put this on there. Yeah, I took this one out. Orthogonal vectors means perpendicular, and you could have just found the slope because you're given y and x for each one of those, and then you just divide y by x to find the slope, right? Rise over run, and whichever two have the same slope, those are the one. I'm sorry, whichever two have the negative reciprocal slope, those are the two that are going to be your answer. But I took it out, so you don't have to worry about this problem. Hopefully that helps. Are we going to be given a polar graph with the values? That's a good question. Let me check. We've got to open up the free response here. I assume you mean like on the test that we had before, where you had to graph the no. So this one only has, oh man, I think they totally messed that one up. This one does not have all the values, all the angle values around it. You'll have to fill those angle values in. Sorry about that. It's not like the other one. while I'm waiting here, I'm going to go ahead and just go through this test here. And I'll just go through the multiple choice and kind of give you some ideas of what you want to know, okay? Okay. Okay, here I'm back. My head is really hurting. I took some medicine earlier, but it's just not going. So I'm not going to be able to keep going for too much longer. I'm thinking maybe 15 minutes, half an hour at best. Then I'm going to have to go to bed because it's killing me. But I'm going to do my best to help you guys out. So I'll just kind of go over quickly what each problem is going to look like. And hopefully that helps you on your study. Number one is a unit circle type question where you have to find the sine or cosine of an angle that's in the unit circle. So just remember that the x values are your cosine and the y values are your sine. Number two, you're going to need to do something with parametric equations. So know how to eliminate the parameter to find the rectangular equation. Number three is going to be an inverse trig question that you use the unit circles. So asking you like the inverse sine or the inverse cosine of √3/2 or negative √3/2 or something like that, where you have to find the inverse. So again, remember that you have those restrictions that you have to take into consideration, and remember that you're looking for the angle where the x value for your cosine or the y value for your sine. Number four is a simplified problem, so it shouldn't take you too long. There's only a few steps, so if you do this one and you are taking like 8, 9 steps to simplify this, you've taken way too long. It should only take about 3 or 4 steps at most. Number five is a right triangle problem where you have to use SOHCAHTOA to find a missing angle, and then use either a double angle or a sum formula to solve that. So we did a couple of those problems before. You should be able to do that. Look at those notes on that one. Number six is another unit circle problem where you have to find either the cosecant, secant, tangent, or cotangent of an angle. So just remember that the secant is 1 over cosine, the cosecant is 1 over sine, tangent is sine over cosine, and the cotangent is cosine over sine. And then you have to put the y over the x or whatever. You might have to simplify because the answers are in simplified form. Number seven is going to ask you to identify the graph of a sine or a cosine function that has a change in its amplitude and its period. So remember that the bigger number, the value is multiplied by the x in your sine or cosine, the shorter your frequency is, so the more times it goes up and down in your 2 pi. Okay. Number 8 is a combination of step-by-step graphing and a trig function. So it could either be what is 1 over sine, or what is the absolute value of sine, or what is the square root of cosine, or the square root of sine, something like that. Number 9 is going to be an inverse of a regular function. So something like what would be like the inverse cosine of the tangent of 2 pi over 3. So you have to first find the inside part, and then you have to find the inverse of that. Again, using the unit circle. These are all the multiple choice problems, by the way. Number 10 is another simplified problem where you're going to have to, excuse me, it looks like you're going to really want to change things into sines and cosines. Number 11 is a stat or calc problem, depending on what you're doing. I didn't open the calculus ones. I only opened the stat ones. So I'm not going to give those away. I already told you what those were. So just know that that's going to be that one. Number 12 is one like Vinay just asked, how do you find the same point on the polar coordinates? I'll give you a point. You find one of the four that is the same one. Number 13 is another inverse, but this time we're doing an inverse secant cosecant problem here. So you have to identify that in your unit circle. Number 14 is another calc or stat question. Number 15 is converting degrees to radians. So know how to convert degrees to radians or radians to degree. It's one of those two. And then another simplify. So you'll have to, that's I think the third, simplifying trig expressions on the test here. So that would be the first 16 problems in the exam. The next group of problems, we're on 17 now for the calculator section of the multiple choice. The first one's going to be finding the first two, magnitude and direction of an angle, or of a vector. So I'm just going to give you a vector. I'm going to say find the magnitude and direction. All right, straightforward as that. Number 19, 20, and 21, I'm going to give you a function. You have to find the amplitude period and the phase shift. Number 22, I'm going to give you a triangle, and you need to use either the law sines or law cosines to find a missing side. And then I'm going to ask you to find the area of that triangle in the next problem. Number 24 is a stats problem or a calc problem. So know which one, know how to do those. Same thing for 25. 26 is another triangle problem where I'm going to ask you to find the missing angle. So you'll likely need to use the law sines or law cosines again. Again, none of these where you have to find the missing side or angle, you're going to have to use SOHCAHTOA. They're all law sines or law cosines. Number 27 looks like a sine or cosine problem from the unit circle where you need to do a coterminal angle. So something where you have like a bigger value than that's in your unit circle that you have to convert into a value that's into your unit circle, then find the sine or the cosine of that. 28 is a bearing problem, so basically just being able to convert bearing into directional angle or compass direction. Number 29 is being able to plug in a value into a parametric equation. And number 30 is identifying a rose. So know how to find the equation of a rose given the number of petals and how long the petal is. That's 30 questions on the multiple choice. On the free response, now I'm looking at the stat one right now, not the calc one. Okay, so there's two parts. There's a calculator and a no calculator section of the free response as well. On the calculator section, it looks like number one is going to be one of those vector problems where you're given, you know, a word problem and some information, probably three vectors, one that's going directly on one of the axes and the other two vectors somewhere else. And you just have to find the components, add them together, find the resultant, find the magnitude, find the direction. So that's where 10 points is pretty much half of that first section. And then you have a second problem where you're going to have to find the another word problem. So both of these are word problems. Oh, great! You know, you're so happy that they're both word problems. I know. I can sense your feeling right now through the computer. But the second word problem is going to be a law of sines or law of cosines problem where you have to draw the triangle given the directions from the problem and then use law of sines or law of cosines to complete the triangle to answer the question. I can't give you much more than that, but I can tell you like what you're doing. And then you'll have to find the area. So know how to do those Heron's formula, know how to find that other area formula. Okay, so that is the calculator. That seems to be the same for both calculus and statistics. So That's the calculator required. The no calculator, I better make sure that that's right. Give me 1 second here. That's the correct. You know, I was redoing this test and I made it shorter than it originally was. I just kind of, you know, didn't want to make it too long for you guys. All right, that's the same as that one. I should have 3 of these. What happened to the other one? Uh-oh. 1, 2, 3. Should have 4. I wonder if I dropped one. Well, uh-oh. Shucks. I bet you it's still in the car. Yeah, that's going to be what you guys have on the. So you both have the same. Stats Calc has the same section for the calculator required part. The no calculator part. The first 2 problems are going to be the same for both. It's going to be one verify question, which we just did an example just a second ago. And then it's a sketch the graph of a polar equation. I'm going to tell you right now, it's not a rose. So be able to graph something that's not a rose. And then the third problem for the stats is all the vocabulary you're matching. And for the calc is the problem, you know, the problem we just went over, which was a limit problem. And that's the final. So I pretty much told you what each problem was on the final. I didn't give you specifics as in like what they actually like are, but I gave you pretty much what each one is going to look like. Hopefully that's going to help you. Do you think you'll be able to do a live stream tomorrow for 6th period or add the key on Classroom? I can try. I don't think I'll be able to do a live stream tomorrow night. Hopefully 6th period was on here today, but we'll see. You know, we'll see what 6th period has. If they're going to ask for that too, you know. My time is precious, guys. I do want to give you as much time as I can. Oops. You may not use your workbooks. Is that stats or calc? I'm not quite sure what you mean with is that stats or calc. I think I went over everything for each of them. The only difference is the calculus one, where I said there were stats or calc problems. I didn't specifically tell you which ones they are. I could tell you right now which ones on the multiple choice they are. For the stats group, you'll have, let's see, there's a categorical or quantitative variable. There is determining if it's skewed left, skewed right, or symmetric based on your mean and median and how they compare. You'll have, what was the other one here? I believe it's a normal distribution, so solving a problem with a normal model, and finding the fences, I think. I think it's finding the fences. For the calc group, it's going to be, I have my notes here. Determining the slope of the tangent line. So I made these pretty, not as hard as the ones that were on the previous test. So it's just straightforward. Find the slope of a tangent line. I give you the function and the next value. And then a limit where you have to simplify the function inside and then find the limit. So that's that one for the calc group. Let's see what the other one was. Sorry, guys, my papers are all over the place. I did not have a chance to open them up, but I'm a little worried because I'm missing one. Determine the area under a curve of f of x equals blank from blank to blank using a blank hand Riemann sum with n equals blank equals subintervals. So it looks like you're going to be doing a Riemann sum. And then an integral evaluated. Now, I would recommend that you know how to do an integral, especially of a square root or a cube root or some sort of root. Okay. Let's see. Darian asks, how do you know what points to use when graphing polar graphs? Okay. Let me go to my... Dude, it is getting hot in here. I think I'm right under the lights, making my headache worse. All right, I got an answer for you, bro. Here it is. Let's say you have, I don't know, r equals like 3 plus 3 cosine theta, something like that. That's not a rose. That's a limousin. And when you have a limousin that's not a rose, you're just going to pick. You're going to pick the theta values of 0, pi over 2, pi, 3 pi over 2, and 2 pi. And then 1 in between each of these. And the one you're going to pick is the one that's going to give you an answer that's 1/2. So for cosine is the x value. Now, if we looked on the first section of the unit circle, the one that's going to give me 1/2 for my x value is going to be pi over 3. So that's going to be the one that goes here, because I want this to be 1/2. I do not want it to be square root of 3 over 2. I don't have a calculator for this section, so I don't want to have to try to add 3 plus 3 times root 3 over 2 and estimate that. It's much easier. You know, I'll make this even easier. I'll make this a 4. To deal with 1/2, because if I had 1/2 here, so if I plug in pi over 3 in here, I'm going to get 4 plus 4 times 1/2, which is 4 plus 2, which is 6. See, I can do that. That's easy. If I had a root 3 over 2 in here, I couldn't do that. That's too much estimating. So that's the one I'm going to pick. I'm going to look on the unit circle. I'm going to pick the one that's going to give me 1/2. For cosine, it's going to be pi over 3. For sine, it's going to be pi over 6. And then I'm just going to keep filling in. So if I do 0 here, I'm going to have 1. I'm going to have 8 there. And I'm just going to keep plugging in. Pi over 2, and this is going to be 2 pi over 3. And pi over 2 is going to be 0. It's going to give me 4. 2 pi over 3 is going to be negative 1/2. So 4 plus 4 times negative 1/2, which is 4 minus 2, which is 2. That's going to be, pi is going to give me negative 1. So that's 4 minus 4, which is 0, you know, and so forth. And I'm just going to want to make sure that I'm going to go left counterclockwise when I plot this, okay? So that was the question, was how do I pick the values for that? Hi, Mariah. You are going to get a blank unit circle. I said that one earlier. What is an integral? Oh, come on, Vinay. Vinay, were you doing the calculus one? This is what I'm talking about. Okay, this is an integral, the area under the curve. All right. So you change this to the 1/3 power. You add 1 to that, so that's plus 3. That's 4/3 divided by 4/3, evaluated from 0 to 3. 3/4 x to the 4/3, evaluated from 0 to 3. We plug the 3 in. and we do that. Okay, for now, because we're going to plug in the 0 too, but the 0 is going to give me 0 in this case. So 3/4 times 3 to the 4/3. The one I'm going to have on the test is going to be able, you should be able to simplify this by hand. Okay, good. All right, I have time for a couple more questions, and then I am going to head out to go brush my teeth and go hit my pillow because I'm tired. And while you guys are studying, I will be sleeping. Sorry, I didn't mean to laugh at that. All right. All right, guys. Keep it in here for a minute here to see if there are any more questions. Hopefully I gave you some good information. It's worth it to come in here, even though I don't know if I was greatly helpful. At least you have an idea of the layout of the test and you know exactly what's going to be on it. There's no surprises. All right, no surprises. Yeah, I did. Sad face. Okay. I love you guys too. All right. Hey, just think of it this way. How many other teachers take the time at 8 o'clock at night to do a live broadcast of a review session? I don't know. You tell me. I know of one. I know of one. What time will be in my class Thursday? I'm guessing 7:15, 7:30. I don't plan on being there any earlier than normal. You guys are welcome. Like I've said before, and I'll say this again, and you guys know this. You know, it's always great. I get the best students coming on to do this, and it's reflective in your grades when you come on here and you do the extra things that you need to do. And when you do those extra things and go above and beyond, that's why you have an A. That's why you have the grades that you do. That's why you do so well. It's it's students that get complacent that don't do as well as they should be doing. My time is important, and and I've said this before. My number one priorities in life are my kids, my family, and my students. And you guys are very important. So that's why I spend the time to make sure that I help you and you're prepared and you feel confident in coming into this test. And if I see you next year or years down the line, that's what I want you to get out of being my student, is that you can count on me, that I always have your best interests in mind, and that my goal is that you do well. If you're not one of my students and you're watching this broadcast either live or you're doing it or you're watching it later, I hope that you can find that in a professor or teacher that you have, and that you know, if you want to come and watch some of my videos, hey, just know that my number one goal is that people learn, that my students learn math, that they feel confident in math, and the effort that they put in is reflected in how well they do and how much they understand. Okay, so that's it for me in this broadcast, ladies and gentlemen. Hopefully you've gotten something out of this evening, and good luck, and we'll see you soon. Bye.